What's up, guys? Welcome to another episode of the CotAcasT. My name is Brian Bermudez, and I'm the host of the Craft of the Air podcast, the aviation podcast that expands your knowledge in each episode. Join us as we explore the untold world of aviation together. I'm so glad that you guys are tuned in for another episode, and this one is it's going to be a deadly one, man. Episode 29. We explore the possibility of these just deadly parallels hitting the news, the Ocean Gate tragedy of a submarine that suffered a catastrophic, a devastating tragedy. And we look at the similarities, and we look at just some instances where aviation and nautical, vessels and incidents, how they connect. We discussed the importance of maintaining two different methods of transportation, aircraft and underwater vessels. And there have been many tragedies that have resulted from the lack of maintenance, regulations. We also discussed the similarities and the differences between aviation and nautical regulations. What we uncover and some of the tragedies that we look through and some of the similarities, it may shock you. First things first, today's episode of the CotAcasT is brought to you by Craft of the Air. Stuck on ideas? Looking to facilitate advances in aviation maintenance? Consulting by Coda possesses unique resources like comprehensive advice, detailed analytic reports, and cutting-edge data on innovative solutions to empower you to make confident decisions to elevate your aviation projects and tasks. Are you an A&P student? Need a refresher? Cram by Coda offers consolidated reviews of aviation maintenance tailored for you by an A&P subject matter expert. Ensure you're fully prepared to excel in any aviation exam. Visit www.craftoftheair.com. Again, that's www.craftoftheair.com today and learn everything Coda can do for you. Craft of the Air, our craft is of the air. So now, I kind of broke this up into, three parts when I kind of wrote this and I looked into some research into this, and just what a tragedy. The world now knows the name of the company Ocean Gate, due to a recent tragedy of this submersible that it imploded on its way to view the Titanic wreckage site. 5 people lost their lives due to the flaws in the submersible vessel Titan. And they were traveling in this vessel. The Coast Guard announced the deaths from a, quote, catastrophic implosion, end quote. And just a tragedy. Now, it's when you look into it, experts had cautioned that under, intense pressure at extreme depths, Titan's hull could implode, which would result in, instant deaths from anybody that was on board this vessel. Quote, I don't think people can appreciate the amazing energy involved in the destructive process of an implosion, end quote. This was Bob Ballard, a member of the team that found the Titanic wreck in 1985. He told ABC News, quote, it just takes out and literally shreds everything, end quote. And now, while Ocean Gate Expeditions, which owned and operated the craft, they touted Titan's, roomier cylinder-shaped cabin made of carbon fiber. Industry experts say that it was a departure from a sphere-shaped cabins made of titanium used by most submersibles. Now, the 23,000-pound vessel was made of, quote, titanium and a filament-wound carbon fiber and had been, quote, proven to be safe and comfortable vessel that could withstand the enormous pressures of the deep ocean, end quote. That was according to Ocean Gate on their website. So now, while carbon fiber has long to be used in, the aerospace industry, it's interesting to see where it's proven in the industry, but not necessarily proven in terms of nautical, in terms of being able to withstand deep sea pressures. The wreckage of the Titanic lies at a depth of, about 13,000 feet. And that's actually significantly deeper than the roughly 2,000 or 3,000 feet that a typical U.S. Navy submarine descends to. A lot of people don't realize that. This Titan experimental craft was going to a depth of 13,000 feet. Most U.S. submarines, Navy submarines, go to depths of 3,000 at that. Now, at the Titanic depths, we speak about pressure. The water pressure at these depths of the Titanic, about 13,000 feet below the surface of the ocean, it's nearly 400 times more than what we would see at the surface of the ocean. And this is, what experts were going through when they looked at everything that Titan was facing. Some 6,000 pounds would have been pressing down on each square inch of Titan's exterior. 6,000 pounds per square inch. Quote, it's a design that has not been used in this way at this depth, end quote. Kemper said this, comparing the submersible to a balloon. Quote, all it has to do is fall in one spot and the game is over, end quote. Now, in contrast to a U.S. Navy submarine made of carbon steel, this is a tried and true, tested material. It's just so interesting to see how everything really played out. Captain David Marquette, a retired Navy submarine commander, said, quote, when we look at a material like carbon steel, quote, it's tried and true material, and it's reliable and thoroughly understood, end quote. That's well said. And this is something that has been tested over time. Now, carbon fiber, the former sub-commander said, is really a relatively new material, especially for, building submarine hulls. He said, he went on to say multiple repeated dives, inspections, x-rays, ultrasounds. They're all needed to fully understand how the material responds to stress and pressures over time. And really the key there is over time. Not necessarily sure if they had enough time to thoroughly test out these pressures and these stresses on the hull over time. Titan was diving at 10 times the deeper than a Navy submarine, which meant it was undergoing 10 times more pressure. It was interesting. A Northeastern University physics professor likened, and he went on to quote, say, humongous pressure to the force of a whale biting on somebody, end quote. Now, though Titan had a composite hull with inbuilt sensors that could withstand high pressures near the seafloor, any defect could have resulted in really a catastrophic implosion. Associate Professor Eric Fuso, Director of Shipbuilding Hub at a university in Australia, he went on to say that this implosion would have occurred in about 40 milliseconds. 40 milliseconds. He went on to say, quote, the passengers probably would have had no idea what happened, end quote. Now, Titan had been made of more than 24, it had made more than 24 deep sea dives, but these deep sea dives that it underwent, it may have been putting, and it was definitely putting repeated stress on the hull. But how much stress it was putting on the hull, or to what extent, that remains to be seen. You know, it's interesting. The stress could have potentially caused delamination, you know, a horizontal splitting of the carbon fiber hull. A similar disaster occurred in 1963, and this was interesting. In 1963, when the USS Thresher, this was a nuclear powered submarine, it likely imploded when it exceeded a test depth after a series of other failures. Now, this was a tragedy. Killed were 129 soldiers and civilians, and they were on a routine test dive off Cape Cod. Very, very unfortunate with that. Now, as I go into part two of this, you know, there have just as there have been instances of nautical disasters due to the pressure of the ocean and the weakness in nautical vessels, you know, there are certainly instances of aviation disasters that can, you know, have been attributed to cabin structural failures or compromises in the integrity of the fuselage. And we looked through a couple of those examples in this episode of the CotAcasT. And very interestingly enough, you know, both of these systems are very similar in the sense where we know that pressurization is the ability of the fuselage, the aircraft fuselage, to withstand forces associated with, you know, increase in pressure inside the structure versus the ambient pressure on the outside of the aircraft. You know, and when we look at these types of things, you know, to pressurize a portion of the aircraft, you know, the cabin, we have air that is much higher than that of the outside atmospheric pressure. And we have a fuselage that must be sealed. Very similar to that of this submersible that we've all been looking at in the news and getting the attention of. And when I think of aviation, I think of Aloha Airlines Flight 243. Now, this is going back to 1988, and this incident involved a Boeing 737-200 aircraft, and during the flight, a section of the aircraft's fuselage, including a significant portion of the roof, peeled away due to metal fatigue and corrosion. Now, the failure resulted in a rapid decompression of the fuselage, and this led to the ejection of the flight attendant and the death of one passenger, unfortunately. And, you know, pilots managed to make an emergency landing, and subsequent investigations really highlighted, you know, issues related to maintenance, aging aircraft inspections, structural fatigue, you know, some similarities here. At the time, though, of this incident, it's worth noting. At the time of the incident, according to the NTSB, the plane had, quote, had accumulated 35,495 flight hours and 89,680 flight cycles, which are the landings. The second highest number of cycles in the world for the Boeing 737 fleet, end quote. So really on that final flight, however, the pilot suffered, you know, an explosive decompression as a result of structural failures. And this was caused by, you know, according to the report, quote, significant banding and fatigue damage, end quote. Now, you know, investigators determined, you know, this could have likely been avoided. You know, more meticulous safety inspections, protocols, they probably should have been practiced, you know, as the accident led to more frequent and thorough checking of the aircraft cracks and rivets. You know, there was obviously, you know, somewhat of a failure in the maintenance program to catch, you know, some of the errors. Like, yes, I have to say it, as an A&P, I have to say it. Now, the NTSB report found that, quote, the probable cause of the accident was failure of the Aloha Airlines management to supervise properly its maintenance force, and the failure of the FAA to evaluate properly the Aloha Airlines maintenance program and the airline's inspection and quality control deficiency, end quote, amongst other factors in this, you know. But it's interesting, really, this week, paraphrasing a late NTSB colleague, Mr. Marcus, he said, quote, in essence, this was not something we could have reasonably foreseen. He went on to say, quote, this was unfair to say the FAA ignored issues with the maintenance department. It was unfair to say that Boeing had not done adequate engineering. It was a case of this was just something we didn't know before, end quote. Now, it's very interesting. Hazel Courtney, the president of International Federation of Airworthiness, say that 3 times, says that the factors behind Aloha Airlines accident were, quote, not as if someone would just flagrantly not doing their job. Everyone was trying to do their job, end quote. And the advice from Boeing, she tells the Independent, quote, was not really collaborated around the aircraft that worked that hard. So Aloha probably should have made a tighter program up when they went with that kind of default program. The program wasn't quite good enough for what the aircraft was being asked to do, amongst other things, she said, end quote. And it really goes on to my part 3 of this. There are, regulation and safety oversight of aviation and nautical vessels, including experimental submarines, involved in the distinctive frameworks due to different operating environments, characteristics of the industries, and we look at some very, very similar aspects of both of them. I think of 4 major aspects in the regulatory, bodies of both aviation and maritime industries. We both have regulatory bodies responsible for, establishing and enforcing safety standards. In the United States, we have the Federal Aviation Administration overseeing aviation safety, and we have the United States Coast Guard and Maritime Administration, MARAD, that they have these responsibilities for maritime safety. We also have safety standards. Aviation, maritime sectors have established safety standards and regulations that really ensure safe operations of respective vessels, aircraft, experimental submarine. But these standards, they cover areas, such as equipment requirements, operating procedures, crew qualifications, emergency response protocols, maintenance practices, even. And that goes into really, my third point with similarities that we see there, inspections and audits. Both aviation and maritime industries conduct these inspections and audits to monitor compliance with safety regulations, regular inspections, scheduled, unscheduled checks to perform and really verify the condition and the safety of vessels, equipment, operational practices. And with operational practices, you try to prevent, tragedies from occurring or accidents from occurring. And when you think about accidents, both aviation and maritime, they both, accidents undergo thorough investigations to determine causes and contributing factors. The National Transportation Safety Board, the NTSB, they investigate aviation accidents in the United States. You also have the CG, United States Coast Guard, investigating maritime accidents, including those involved with, nautical vessels. But with the similarities, they really end there with aviation and maritime. And when we look at the differences, they're quite significant when you really dive into it. The operational environment. Aviation operates primarily, in the air. We would like to be in the air. We wouldn't have the aircraft on the ground too long. While maritime obviously operating in water. Different environments are going to pose unique challenges and risks, necessitating different safety considerations. For example, aviation will focus on aspects such as airspace management, navigation aids, weather monitoring, while you look at maritime and look at operations require attention to, waterway navigation, marine charts, collision avoidance. And so there's differences there. Certifications and licensing, yes, there's certainly differences. In aviation, aircraft and personnel, pilots, engineers, we undergo certification processes. And aircraft themselves must meet specific airworthiness standards, very strict airworthiness standards. Pilots, mechanics were required to have licenses and certifications, federal exams, certifications, and qualifications here. In contrast, nautical vessels, including experimental submarines, they don't necessarily have the same certification requirements for the vessel itself and for the crew members. I'm not talking about the captain. Now, operational limitations, aircrafts, we're going to operate within defined airspace, with established rules and procedures, follow air traffic control instructions, operate in accordance with defined, flight paths. Nautical vessels, on the other hand, including the experimental submarines, they have more flexibility, in terms of their operating areas and their routes. They still need to adhere to navigational rules and regulations, but to specific water bodies, but there's definitely more flexibility there in terms of the operating areas. And really what comes to mind lastly in the differences here between aviation and our maritime, our safety culture and reporting. The aviation industry has a well-established safety culture that emphasizes the reporting and analysis of safety incidents and near misses. This culture really, it promotes open communication. You're learning from mistakes, implementing safety improvements. In comparison, maritime industry is still very much evolving in terms of safety culture, reporting systems for incidents, near misses. They're not as standardized or widely adopted. In conclusion to this, there have been tragedies over the years, both aviation, nautical, involving lack of maintenance and lack of testing, regulations. Thankfully, these incidents, they've been rare, thankfully. Nautical vessels such as experimental submarines, they're not as closely regulated as aircraft are. Had the Titan submersible been constructed with the appropriate materials to withstand the pressure of the ocean, could this implosion have been prevented? Experts have stated the carbon fiber used had not been studied thoroughly to determine how the material responds to stresses and pressure over time. The Titan had been made more than 24 deep sea dives, and this really put repeated stress on the hull. If the Aloha Airlines fuselage in 1988 had it been properly inspected, could that incident have been averted? The incident sparked a change for aviation safety. Could Titan change the nautical industry the way that the Aloha Airlines Flight 243 changed safety for aviation? Should regulations for experimental submarines be more strict? Probably. Especially after that, in my opinion. That about wraps it up for this week's episode of the CotAcasT. Before we wrap it up, I'd just like to, my prayers and thoughts, condolences to the family and everybody associated with that tragedy with OceanGate, because it is a tragedy at the end of the day. And I hope that the founder and the members on board or we're at peace, at least. That about wraps it up for this week's episode of the CotAcasT. If you have not done so already, check out the Craft of the Air website at www.craftoftheair.com. Again, that's www.craftoftheair.com, and get your free initial consultation today. Craft of the Air, our craft is of the air. Comments or suggestions about this or future episodes, let's get in touch. Visit the www.craftoftheair.com website, head over to the contact section, put CotAcasT in the subject, and we'll be getting in touch right away. Thank you again, guys, for listening to today's episode of the CotAcasT. Be sure to follow and subscribe to the Craft of the Air Instagram, the Twitter, and our live YouTube channel for the latest CotAcasT and Craft of the Air updates. Please rate and review the CotAcasT. We're now streaming on Spotify, Apple, Prime, Pandora, Google Podcasts, YouTube, pretty much every single platform possible. You just have to thumbs up, subscribe, and send it to everybody. I appreciate you guys listening or watching. Thanks again for joining us, and we'll be seeing you soon. Be safe, guys.